Welcome back. This is video 5 of 6. I hope it was interesting for you to generate videos, even if they were short. Perhaps some tools did not do what you wanted. Perhaps you should try multiple tools and see which you prefer. I hope you tried having the chatbot generate a presentation. Let's look at the 5th assignment. Part A is music and speech. Try any of the following as you wish. Text to speech in different voices, AI voice generation, using 11 Labs or Natural Reader. Music generation. Text to music to describe the music to be generated. Some tools accept input lyrics, dialogue, or narration for a single voice. Suno, Udio, Boomi, Google Flow Music, Gemini Tools Create Music, 11 Labs Music, and Sondo AI. AI source separation or stem separation. Separating vocals and instrumentals from a song. UVR Vocal Remover, Moises AI, Lalal AI. Part B, Other Document Creation. Use chatbots to create any of these kinds of documents. After you create a document, you could prompt for changes, or you could have a chatbot summarize the generated document. If you click these links, I give you example prompts and guidance from ChatGPT. So you could create a poem, limerick, or haiku, the outline of a story or a screenplay, or for a comic book or a graphic novel, a short story, song lyrics, a structured plan, a learning plan, or breaking a complex plan into manageable steps, or a spreadsheet. You could upload something you have written and have the chatbot make corrections or rewrite it with more polish or in a different style. Now let's continue with more information about chatbots. Context, the context window, and guardrails. You enter your prompt in the chatbot's prompt box. The chatbot sends your prompt to the large language model. The language model generates its response. The chatbot displays the response. Actually, it's more complicated than that. A few times during this course, I have said that memories and your chat history provide context for your prompt, but I intentionally did not explain this earlier. Now let's learn about the context window. In this diagram, the large gray box is the chatbot. Your prompt enters the chatbot from the left, and the chatbot outputs the response to you at the bottom left. The chatbot software is conventional deterministic software running in a general-purpose compute server. It is separate from the generative AI large language model processing, which is called inference, which I am showing as the smaller box at the top right. There are multiple large language models that the chatbot can use: newer or older, more powerful or less powerful, slower or faster. The context window, shown here inside the chatbot on the right side in red, is a data buffer, container, or data structure into which the chatbot places your prompt, the blue arrow, and other information, the black and green arrows. Before sending it to a language model inference server, the thick black arrow at the top. The inference server uses the language model to process the information in the context window, generate its response, using its trained data, and place its response in space remaining in the context window. Then the inference server returns the context window to the chatbot. The chatbot processes the response and outputs the response to you. You communicate with the chatbot. The chatbot communicates with the inference server, transferring the context window. The language model comes with all its trained weights for which words most often follow which other word, following which other words. We will learn more in the 6th video. The language model does not access the web and does not have copies of the documents and web pages on which it was trained. The chatbot has more information about you, your chat history, than can be sent in the context window. One context window is the entirety of the information that the language model has available from you or about you to generate its response to a prompt. The language model cannot ever ask for more information in order to generate this response. The language model and inference server have no memory of previous context windows and no memory about you. The context window is what it gets. The inference server and large language model are like a software robot that takes in a context window request from anywhere in the world, does many mathematical computations, generates its response, returns the context window response to the requester, and then returns to its initial state and remembers nothing. Many AI data centers have many racks of special purpose servers dedicated to inference and nothing else, whereas the software of the chatbots runs on general purpose compute servers in the data centers, and training runs on different special purpose servers, separate racks, separate areas of the data center. The large language model inference servers process context windows from millions of people and remember nothing. The chatbot servers remember your chat history, your memory, your preferences. Now we will look at the other information the chatbot puts into the context window. Details vary among chatbots, so treat this diagram as for ChatGPT. For now, ignore the two boxes of chatbot guardrails here and here. We will talk about them later. The chatbot places its system instructions or system prompts, governing instructions or base directives into the context window before your prompt or anything else. The system instructions tell the language model how to act and respond. System instructions define language model behavior, safety rules, tool use, operational boundaries, refusal guidelines, content restrictions, formatting requirements, error handling rules, and product-specific features. The system instructions are hidden from the user, are not published, and are not meant to be discoverable. If your prompt attempts to remove, undermine, or expose the system instructions, that is called jailbreaking. To prevent or reduce jailbreaking, the language model is trained with the system instructions and with attempts to jailbreak it. Today's models include an instruction hierarchy system to deter user prompts from overriding system instructions. Some tools have a developer mode and developer instructions, which we will not cover, but system instructions are higher priority than developer instructions, which are higher priority than user prompts. However, the instruction hierarchy system is learned behavior by the language model, not deterministic code. I will give you a link to Chatbots Explaining System Instructions. Any custom instructions and personalization or preferences that you have set in Settings get included in the context window. Some chatbots lump these with system-level instructions. Some chatbots include these for temporary or incognito chats. Your prompt gets included in the context window. We'll cover guardrails later. If your prompt uploaded a document containing text or referenced the document you had previously uploaded, for example in a project, the document text will get included in the context window. Large updated documents don't necessarily mean the entire document is present in the context window at all times. The system may retrieve relevant portions as needed rather than inserting all pages in the context window. Therefore, a project may contain far more information than would fit into a single context window. I don't know what happens for image uploads. You could ask a chatbot to explain it. If your prompt invokes a web access or the chatbot decides to do a web access, the retrieved information gets included in the context window. This is sometimes called retrieved tool information. I don't know how this works, and it may differ among chatbots. If your prompt is in a chat in a project, the project instructions that you prompted early in the project will get included in the context window before your prompt. Some context from the project chats may get included, which varies among chatbots. Large projects can accumulate conceptual clutter when many unrelated subtopics exist, many files are uploaded, terminology conflicts, assumptions evolve, or obsolete information remains relevant to retrieval. Sometimes you should split an existing ChatGPT project to declutter. Claude works differently and says you don't generally need to do this. I have not verified this. I created large projects in developing this course. Gemini eventually gave me errors. Creating a new project cleared some errors, but something is still wrong. Perhaps I should have created smaller projects. Explicitly saved memories from when you prompted remember will get included in the context window if your settings enable this, except not for temporary or incognito chats for Claude, Gemini, and Copilot, and possibly ChatGPT now. If you care about this, test it. As you entered prompts and got responses in the past, the chatbot gleaned some information about you, your use of the chatbot, and your preferences for responses, when permitted by your settings. Some of this gleaned information the chatbot saved as gleaned saved memories. Either account-wide gleaned memories or project-local gleaned memories for chats within projects, for Claude and Gemini, not for Copilot or ChatGPT by default. When permitted by your settings, gleaned saved memories get included in the context window of ordinary chats, not temporary or incognito chats. For a prompt in a chat in a project, Claude and Gemini will include the gleaned saved memories for that project and the account-wide gleaned saved memories. If you don't want account-wide gleaned saved memories getting included for a prompt in a chat in a project, then stop using non-project chats and put them into a miscellaneous project so there will be no account-wide gleaned saved memories. When permitted by your settings, some of your recent chat history will get included in the context window for this prompt. This information will be truncated when the context window would be full after your prompt is added. A very long conversation may cause older messages to be omitted, partially omitted, summarized, or selectively retrieved when the chatbot reaches the context window limit. In a very long chat, the language model may no longer see exact wording from early messages, even though the conversation still appears in the user interface. Some chatbots refer to relevant chat history. You could ask the chatbot for further information. Because of this, repeating critical constraints periodically helps, and long technical projects can drift over time. Two identical prompts can generate different responses even within the same project. Saved memories generally occupy much less context than a long chat history. Claude says that it includes all prompts and responses from the current chat and any files or images you uploaded in this chat until the context window is full. I have not verified this. System instructions are inserted first in the context window. I assume that your prompt gets inserted last. I don't know the ordering for the other information in the context window, and ordering can influence the generated response. Different bits of information in the context window can be in conflict with one another, adding to uncertainty in the response. I will give you a link to a test of conflicting info in the context window. The context window has now been populated. Now the chatbot server sends the context window and a length limit for the response to an inference server for the intended language model. The language model processes all of the context window data to build its context. Then it generates its response using the context and its trained model parameters, weights, and places its response into reserved or empty space in the context window. The language model's generated response includes text formatting markdown instructions based on the language model's training and your prompting and preferences. The inference server returns that context window to the requesting chatbot server, which processes it further, renders the formatting that the markdown specified, outputs the response to you, and adds it to your chat history. Having so much additional context beside your prompt in the context window allows the language model to generate a response tailored to your history with the chatbot. But it means that the response is not just to your prompt. This can improve the response or muddy the response, and/or confuse your use of the chatbot. Relevant context is helpful. Unrelated context reduces focus and clarity. The context window for a given model has a fixed size, though in tokens, not words or characters. We will cover tokens in the 6th video. Different models have different sizes of context window. Context window sizes have increased over time, which is generally good, allowing longer, more coherent conversations with fewer hallucinations and responses, with the ability to analyze larger amounts of data, and with responses based on more detailed information from you and about you. Paid tier sometimes support a larger context window than free tier. However, the additional context doesn't always mean better responses, and they could be worse. Sometimes you should realize you don't want to include extraneous context and know how to do this. We will cover how to get a clean, fresh response. Sometimes I would like to know what context was included with my prompt. I'm not aware that any of the chatbots will show you what got included in the context window. Nothing in this process is particular to English. Modern language models handle all written languages concurrently and pretty seamlessly. There are not separate language models or inference servers for English, Spanish, Chinese, French, German, Japanese, etc. For other languages, a given model's fluency might be good, variable, or weak, depending on how many documents in those languages were included in training. I will give you links to 3 articles that explain the context window, and 1 document where the chatbots explain context and the context window. Once it was recognized that crafting good prompts was a skill that could be learned and practiced, the industry adopted the term prompt engineering, how to prompt effectively. More recently, the term context engineering may be overtaking prompt engineering, certainly for agentic AI. We can see that context is important, as well as the prompt. Suggestions for a clean response to a prompt. Sometimes you want a response to a prompt to be clean and not reference context from your chat history. You can choose your chat, choose your prompt, choose your settings. You can get a fresh, clean chat by using a temporary or incognito chat. If you want an ordinary chat, you can create a new chat either not in a project or in a new project in Claude or Gemini, though account-wide gleaned saved memories will still go into the context. Prompts. You can add wording such as the following to your prompt. Answer only from this prompt. Ignore earlier speculative discussion. Treat this as a fresh analysis. Do not use prior uploaded documents. Use only the information below. Do not rely on memory or prior assumptions. Reevaluate from first principles. Treat this as a new independent conversation. Use only the information in this message unless external knowledge is required. Ignore all previously uploaded files. Do not use earlier images. Only analyze the file attached in this message. Disregard prior project documents. Fresh analysis. Ignore prior discussion and assumptions unless explicitly restated here. Reevaluate independently from prior conclusions. For this response, ignore any previously uploaded documents and answer only from your general knowledge. Do not reference the files I uploaded earlier. Just answer this question directly. Treat this as a fresh question, independent of our earlier discussion. Set aside the context from earlier in this chat and respond to this in isolation. Respond to this as if you have no prior context from our conversation, only your training knowledge. Please provide an objective, neutral response without incorporating my personal preferences or saved memory facts. Do not use any uploaded files or images for this response. Answer as if this is the first message you've ever received from me. Respond as if this is a brand new conversation with no prior context. I will give you a link to a file with this information. When you ask the chatbot to summarize a document or web page, you might want to include something like, summarize this document using only this document. Don't include other documents or prior commentary from training. In these cases, I believe that the chatbot still puts context into the context window. So This is relying on the language model to follow your instructions. It would be better to limit your context using an appropriate chat and also include this prompt wording. In rare circumstances, the guardrails might change what you entered if they think you are trying to jailbreak the system instructions. You could change your settings to not include memories or chat history as context for prompts, but this is heavy-handed for general use. This might be appropriate for an account that is only doing research. Chatbot guardrails. The chatbots implement guardrails, or safeguards, typically in three places. Pre-processing guardrails that process your prompt. System instruction guardrails that always go into the context window and guide the language model. And post-processing guardrails that process the language model's generated response. The guardrails are not standardized across the industry or regulated by the government, but there is commonality across the major chatbots. Pre-processing guardrails include checking account login and permissions, rate limits, attempts to jailbreak the chatbot, and input moderation. These guardrails can inspect your prompt, your uploaded files, images, and metadata. Pre-processing guardrails are chatbot software, code. Some guardrails immediately reject or respond to your prompt, and that prompt does not get sent to the language model. Major U.S. chatbots today probably include guardrails concerning discussing suicide, self-harm, harm to others, copyright violation, racist content, and some criminal activities. Triggering certain guardrails likely causes that case to be logged, likely for assessment by an AI agent, and sometimes subsequently for human review. For more information, ask the chatbot. In ChatGPT, you can set a trusted contact to be notified in the event a prompt suggests a serious safety concern. Other pre-processing guardrails may transform, censor, or extend your prompt, or remove an image before sending it to the language model, and you may not know it has done this. Some guardrails are implemented as system instructions that always get included in the context window. Post-processing guardrails process the language model's generated response before you see it. These include policy checks, detection of personally identifiable information or prohibited content, source citation checks, and output moderation. These guardrails can remove some information from the response, add warnings to the response, or replace the response with a refusal. Some chatbots implement guardrails outside the chatbot, between the chatbot and the language model. These are software, code. I believe Anthropic's input and output classifiers work this way. I don't know whether this replaces the pre-processing and post-processing guardrails in the chatbot or supplements them. I believe Anthropic added an input safety classifier here to reduce jailbreaking to get its Fable 5 model approved by the government. This raises the question how well protected ChatGPT, Gemini, and Copilot models are against jailbreaking. Models are generally trained with their system instruction guardrails, but some language models, such as Claude's, may have had further guardrail training. I will give you a link to the chatbots explaining guardrails. This completes the 5th video. I encourage you to spend time on the 5th assignment before continuing to the 6th video.